Okay, number 7, find the equation of the tangents to the curve, okay, at the points where the curve crosses the x-axis. Okay, so again, because we want the equations of the tangents, we need the gradient functions. If we differentiate, this one's straightforward, that becomes 2x, that becomes 3. Differentiate that, you get 4y dy dx. Differentiate the 4, you get 0. So we take this over to the other side. Okay, that's what I would do there. Okay, it was straightforward, isn't it, to differentiate this, but if we take that over because it's negative, we get 4y dy dx. And then we can divide by that 4y, so we get then dy dx is equal to 2x plus 3 divided by 4y. Now we're given information here, we're not given any points, but we said, look, where the curve crosses the x-axis. Now if we think about it, the x-axis, okay, well, what's true when the curve crosses the x-axis in terms of a coordinate? Well, we don't know what the x value is going to be, but we certainly know what the y value is going to be. Yeah, because if you think about it, on the x-axis, the y value is 0. So on the x-axis, y is 0. Now this is slightly interesting because when y is 0, look how dy dx, what's going to happen to it? Okay, I don't know where x is, but look at the bottom there. The bottom's going to be 0, isn't it? So dy dx is going to have 0 as a denominator, and we know when you have 0 as a denominator, it's impossible, isn't it? It becomes out as math error. So what actually happens is, calculator says math error. What's happening is that we've got an infinite gradient. Okay, it's a bit like the tan graph when you type in tan 90, and it says math error, doesn't it? Because at 90, tan 90, it's undefined, it shoots off to infinity, and you draw an asymptote. And that's what's going on here. Our tangent is literally going to be a vertical line. I haven't quite drawn that properly, but you can see what's going on there. It'll be a vertical line. What we don't know is what the x value is going to be. Okay, but clearly it's going to be a vertical line because the bottom is 0. Okay, so question is then, how do I work out the x values at that particular point? Well, go back to the curve, yeah? Okay, so because y is 0, we'll have x squared plus 3x, take away 2 times 0 squared equals 4. So x squared plus 3x, bring that 4 over, minus 4 equals 0. And you've got yourself a quadratic, which we can solve. So we can factorize this. 2 numbers then, and multiply to give 4, so you've got 2 choices, but the one choice that will work is 1 and 4. They've got to add up to give 3, so positive 4, negative 1. So x minus 1 is 0, or x plus 4 is 0. So x will equal 1, or x will equal to negative 4. So we've got 2 tangents in this case. Okay. So if I was to draw it, this curve, you can go onto desmos.com maybe, and you could draw this. You could type the equation in, and draw it for you, and it probably looks something like this, right? I think this is what it looks like. So that will be point 1, and then we've got minus 4, something like that here. And literally on the x-axis, your tangent there touching the point on the curve, and the x-axis is vertical, okay? Now, how do we describe vertical lines? Well, we saw in the last question, horizontal lines are y equals something. Vertical lines will simply be x equals, so in that case, x equals 1, x equals negative 4, yeah? These solutions we found before. Because of course, every point on that line there, x will be 1, and the same here, every point on this line, x will be negative 4.